Hi and welcome back. So in this video we're talking about converting rectangular or Cartesian coordinates to polar coordinates. So in my last video we went from polar to rectangular, and I talked about these formulas that we are going to use to help us do that. So if you want to see where these formulas come from, check out that video. But at this point I'm assuming that you've seen these formulas and you understand how they relate to polar and rectangular coordinates. So our formulas are x equals r times cosine of theta, y equals r times sine of theta, and x squared plus y squared equals r squared. So our main method we're going to use is that we are going to be given x and y, that's what we know, and we want to find r and theta. So we're going to find r first as our first step, and we're going to use that x squared plus y squared equals r squared. We're going to take the x and the y that we know because we're starting with rectangular coordinates, and we're going to substitute them in for x and y. Then we're just going to solve for r. So we'll assume that r is always positive, it's a positive radius, and so we're just going to solve for r in this equation. Then once we have that, we'll move on to the second step, which is to find theta. So we'll use that x equals r times cosine theta and y equals r times sine theta to sub in x, y, and r. So we know the x, we know the y, and then we just found the r, so we can plug in all of this information and then solve for theta. Before we try this out, I just want to give a couple tips. So one of the things that will really help is to be mindful of what quadrant we're in. So we can look at our x and y pair and see if I was to plot those on an xy axis, which quadrant would I be in? And then that can tell us what quadrant the angle should be in that we're going to find, so the theta that will go with it. So it's just nice to have that in your mind to make sure you're getting answers that make sense. Then the other thing to keep in mind is that it might be helpful to simplify the radicals or the square roots that you end up with in your problems. So just to do a quick overview in case it's been a while since you've done this, let's look at the square root of 54 and the square root of 20 and just try to simplify these. So our main method for simplifying radicals, unless you're using a calculator of course, is to just try to factor into something that is a perfect square. So I'm going to write 54 as 6 times 9 because I know that the square root of 9 is 3. And I'm going to write the square root of 20 as 4 times 5 since I know the square root of 4 is 2. Then I can split this up into two radicals, so I have the square root of 6 times the square root of 9, or I have the square root of 4 times the square root of 5. And then I can simplify. So the square root of 9 is 3, the square root of 4 is 2, and I'm left with 3 times the square root of 6 and 2 times the square root of 5. So doing this is just going to help us out when we're trying to simplify things, and so I like to mention it here just to give you a little overview. If you get totally stuck, you can always type these radicals into a calculator, into a website. I like to use Wolfram Alpha. So those are just some options, but just remember that it might help you out to try to simplify if you get to a place where you're stuck. So, okay, we have our basic process and we have some hints. Let's go ahead and try a couple examples. So let's convert the rectangular point 3, 3 times the square root of 3 to polar coordinates. And I'll put my formulas here. So our first step is going to be to find the radius r. So my x is that 3, and my y is the 3 times the square root of 3. And I'm going to put these values into my formula x squared plus y squared equals r squared. So I have 3 squared plus 3 times the square root of 3 squared equals r squared. And now I just need to simplify. Three squared is 9, that one's the easiest part. And then we need to take this squared on this next term, on the y, and distribute it. So I'm looking at 3 squared times square root of 3 squared. I know there's so many 3's, but this example works out nice, so bear with me. Then I'm looking at 9 plus 9 times 3. So when we take the square root and we square it, it goes away. And I'm just going to continue on. So I'm just trying to simplify this left-hand side here. So I'm looking at 9 plus 27, which is 36. So I have 36 equals r squared. So I took the x and the y, put them in the formula, I squared everything very carefully, and then I added them together. So now I'm going to say that r is the square root of 36. I'm taking just the positive square root because I'm assuming the radius is a positive length, and then I'm getting r equals 6. So there we go, I found my radius, and now I just need to go on to step 2 to find my theta. So to find theta, I'm going to use that x equals r cosine theta and y equals r sine theta. And let's go back to my xy point. So I was given 3, 3 times the square root of 3, and this point is an xy, and they're both positive. So this is in quadrant 1. I have a positive x and a positive y, putting me in quadrant 1. And so in my mind, I'm remembering that my angle, theta, should also be in quadrant 1 to match. So let's go ahead and find it. I'm going to substitute in my x and my y, and then 6 for my radius. So my two equations are 3 equals 6 cosine theta, and 3 times the square root of 3 equals 6 sine theta. Now I'm showing you both equations, but you really only need one. Both equations will give us the same answer. However, I personally like to use both and solve them both for theta because it just comforts me and lets me know that I did it right. So remember, we're trying to solve for theta, so I'm going to isolate the trig function by dividing both of these by 6. So I'm getting 3 over 6 equals cosine theta, and 3 square root of 3 over 6 equals sine theta. Then simplifying, 3 over 6 is 1/2, so I'm getting 1/2 equals cosine theta, and square root of 3 over 2 equals sine theta. Now, this should correspond to a value on my unit circle, where cosine is 1/2 and sine is square root of 3 over 2. And if I look at my unit circle, I should see that this is the angle pi over 3. So pi over 3 has a cosine of 1/2 and a sine of square root of 3 over 2. And so I found my theta. This means my final answer in polar coordinates for r and theta is 6, pi over 3. And there we go. What I like to do when I'm done with these problems is just draw myself a little graph to make sure I feel confident with what I did. So if we think about the point that we started with, we had 3 times the square root of 3. So 3 for x, and then 3 times the square root of 3 for y. I typed in 3 times the square root of 3 into a calculator and got that it's about 5.2. So I know that my y value is about 5.2. Then if I think about my new r and theta, this should match up with this point. So the radius is going to be 6, that's the distance from the origin to this point, makes sense to me. And then the angle is pi over 3. So just looking at this, I see that the Cartesian and the regular align, things are working out well, and so I can feel confident that I got the right answer. Okay, let's try this on another example. So let's convert the point -7, -7 to polar coordinates. So we'll start with my formulas again, and the first thing we're going to do is find r. So I know from my point that my x is -7 and my y is also -7. So I'll plug them into the equation x squared plus y squared equals r squared. So I'm looking at -7 squared plus -7 squared equals r squared. -7 squared is 49, so I have 49 plus 49 equals r squared, and together those make 98. So right now I have 98 equals r squared. Now this is just a matter of simplifying, so I'm going to say that r is equal to the positive square root of 98. Remember, we just take the positive square root because we're just assuming that the radius is positive, just like we assume that the hypotenuse is positive. Then technically we are done, so we've already found the radius value. But I really like to simplify these things as much as I can, so I'm going to try to simplify this a little bit. So from the math I've done, I know that 98 is 2 times 49. So I'm going to write this as the square root of 2 times 49, and then I'll split it up into the square root of 2 times the square root of 49. Then the square root of 49 is 7, and so I have the square root of 2 times 7, which means if we rearrange it, that the r, our radius, is 7 square root of 2, or 7 times the square root of 2. To me, this seems a lot more manageable than the square root of 98, and I like having a square root of 2 because that reminds me of some of the things on my unit circle. We see square root of 2 a lot on our unit circle angles. So, okay, we found our r, and now we need to find theta. So my point, -7, is an xy pair, and if I think about going to the left by 7 and then down by 7, this is in quadrant 3, which tells me that we're looking for an angle theta that's also in quadrant 3. So I'm just keeping this in mind as I'm working through this math. Then I'm going to use that x equals r times cosine theta, and y equals r times sine of theta, and I'm going to substitute in for x, y, and r to solve for theta. So x is -7, y is also -7, and then r is 7 times the square root of 2. So now I'm just solving for theta. I'm going to isolate my trig functions by dividing by that radius, dividing by the 7 times the square root of 2. So I'm getting -7 divided by 7 square root of 2 is equal to cosine of theta, and -7 divided by 7 times the square root of 2 is equal to sine of theta. Then I'll just simplify. So I'm getting -1 over the square root of 2 is equal to cosine by canceling those 7s, and the same thing but for sine. So if you've solved quite a few of these trig equations with unit circle values, you might recognize this 1 over square root of 2. We can rationalize this by multiplying by the square root of 2 in both the numerator and the denominator, and so I'm getting that this is really square root of 2 over 2. So as my final equations, I can say that we're looking for negative square root of 2 over 2 equals cosine of theta, and negative square root of 2 over 2 equals sine of theta. And so I'm looking for the angle that has these sine and cosine values. On my unit circle, this is 5 pi over 4. So this is an angle in quadrant 3, that's great. So we're in quadrant 3 as we wanted. And this has the sine and cosine values both as negative square root of 2 over 2. So, okay, we found theta, and now we can write our final point. So our point r, theta, in polar coordinates is 7 square root of 2 and 5 pi over 4. Now, as I did in the last example, I can also draw this out just to make sure I did things in the way that makes sense. So our initial point was -7, which I can see here is in quadrant 3 on an xy axis. And then I can also draw it in terms of polar coordinates. So this radius is going to be 7 square root of 2, and then the angle is 5 pi over 4. So there we go. Alright, that is it for this video about converting from rectangular to polar coordinates. Thanks so much for watching, and I will talk to you in the next one.